Okay, for our next problem, we have a plate with a width of 300 millimeters and a thickness of 20 millimeters. It is to be connected to two plates of the same width, but the thickness is half of it by a 25 millimeter diameter rivets. The plate is A36 steel. The allowable tensile is 0.6 of Fy and the allowable bearing is 1.35 of Fy. The rivet has an allowable shear of 150 megapascals. Now, the question for us to answer is what is the safest load P that can be loaded on the system in kilonewton? So let us first draw our system. Okay. Sabi the same width. So parang the same width pero magkaiba ang thickness. For example, dito yon. So for yung ating meron tayong 4 rivets. Okay. So in cross section, ganito itsura niyan. Okay. Ito, meron tayong dalawang plate, no? In the same width, pero half ng thickness nitong nasa gitna, yung thickness nitong dalawa na to. Okay. So that we can now have our consideration. First is the tension on gross area. Okay, tension on gross area. So what is our gross area? As you can see, if we apply your load P here, okay, this is in this part, there's a thickness of 20 millimeter resisting our force. And also, kapag ka naman na-transfer yung load, meron naman tayong, kasi it would battle between this direction and this direction. Pagka dito naman, meron tayong dalawang 10 millimeter kasi half of the 20 millimeter yung thickness doon. So, in that manner, kahit anong mangyari, meron pa rin tayong thickness of 20 kasi 10 plus 10. But if it's 8, so 8 plus 8, that is 16. So, we will consider the lesser one. Okay. So, tension on gross area. What is our gross area? That is your width multiplied to your thickness. Okay. So, wala sa tayong mention na value of Fy. But since we are given that it is A36 still, we can say that your Fy is equal to 36 KSI. And having said that that is 36 KSI, it is equivalent to 248 megapascals. Or simply, you can multiply 36 to 6.9. Therefore, your force P is equal to your 0.5 of your Fu times your Ag. That this is for your gross section. Okay, so what is the value of your Fu? Fu is for at an A36 steel that is equal to 0.58 or in megapascal, 58 is equal to 400 megapascals. So that is 0.5 times 400 megapascals. Your Ag, your width is 300 and your thickness is 20. The value of P is 1,200 kilonewton. Okay, how about tension and net area? Okay, the tension for net area, so we will consider this as P. And sabi niya, the allowable tensile is 0.6 of Fy multiplied to the effective net area of the plate. So that is P zero point 0.6 of your Fy is 248, and your net area would be 300 minus, we have two rivets which has a diameter of 25 millimeters, so we have to add 2 millimeters. Yan. And again multiply to the thickness of 20 millimeter. So the value of P is 732.096 kilonewton. Okay, next one is we can have your shear on rivets, on bolts or rivets. Okay, how? So if we have a bolt here, it could experience a doubly double shear. Okay, so it would experience a double shear, and our area of shear could be 2 times pi over 4 multiplied to the square of the diameter of the rivet, and that is 25 squared. So we have 4 rivets times your 4 rivets na n, and the total would be 3,927 square millimeter. Therefore, your P in shear is your allowable shear multiplied to the area of shear. So your allowable shear is 150 megapascals times 3,927 rather. Okay, square millimeter. So the shear from, or the force from shear is 589 kilonewton, or 589.05 kilonewton. So we can also have your bearing. Okay. At this point, we will not yet consider your block shear. Okay. It is because your tension in net area does not really exceed your tension on gross area. Okay, so next is the bearing. Bearing. So that would be your force P multiplied to the shear, or the stress for bearing and the area of bearing. Okay, so we have two areas for bearing. The first one is with the thickness of 10 plus 10, that is also 20, and also the other one is 20. So our FP is 1.35 of Fy, 1.35 of 248, and the area of your bearing is equal to your diameter of the rivet multiplied to the thickness times the number of rivet. So we have 25 times the thickness is 20, and we have 4 rivets. Therefore, your force P is equal to 669.6 kilonewton. Okay, so the question for us is to determine the safest value of P. So having our answer from the tension on net area, tension on gross, shear on bolts and bearing, we will select the least among the 4 solved values. And the least is that the force from the shear on fault. So the allowable or the safest value of P is 589 kilonewton. This is the safest value of P.